Today we discuss another condensation reaction of aldehydes and ketones, that is Claisen-Smith condensation reaction. What is that? Claisen-Smith condensation. Okay. What is Claisen-Smith condensation? It is a condensation reaction between an aromatic aldehyde. Aromatic aldehyde means, example, benzaldehyde, aldehydes which do not have alpha hydrogen. That means a condensation reaction between aromatic aldehyde and an aliphatic aldehyde or ketone having alpha hydrogen in the presence of a base will give alpha, beta unsaturated aldehyde or ketone. This condensation reaction is known as a Claisen-Smith condensation. So in Claisen-Smith condensation, it is the condensation between an aromatic aldehyde. Aromatic aldehyde means aldehyde which does not have alpha hydrogen. An aromatic aldehyde with an aliphatic aldehyde, or ketone having alpha hydrogen. So, what is that? It is the condensation between an aromatic aldehyde with an aliphatic aldehyde or ketone in the presence of a base to give alpha, beta unsaturated aldehyde or ketone. This condensation reaction is known as a Claisen-Smith condensation. So once again I repeat, it is the condensation between an aromatic aldehyde. What is the speciality of aromatic aldehyde? Does not have alpha hydrogen. With an aliphatic aldehyde or ketone that should have having alpha hydrogen in the presence of a base to give alpha, beta unsaturated aldehyde or ketone. This reaction is known as Claisen-Smith condensation. So let us go through the equation for this condensation reaction. So what is that? It is a condensation between an aromatic aldehyde with an aliphatic aldehyde or ketone having alpha hydrogen. So aromatic aldehyde, example, benzaldehyde. Okay, look at it here. How will you write benzaldehyde? That means CHO. The actual structure of benzaldehyde is, okay, you can write like this. Okay, here it is C double bond O H. Okay, this is benzaldehyde, this is aromatic aldehyde. And look at here, this aldehyde does not have alpha hydrogen. Because look at here, this is the CO group. Okay, CO group attached carbon is this one. CO group attached carbon is this one. So you can see that here it is alternating double and single bond. So look at here, in this carbon there is no hydrogen. So CO group attached carbon, this carbon is alpha carbon, and in this alpha carbon there is no hydrogen. So look at here, this carbon 1, 2, 3, 4 bond. So there is no hydrogen. So in this aromatic aldehyde, example is benzaldehyde, there is no alpha hydrogen. Alpha carbon is there, but in alpha carbon there is no hydrogen. That means here you can see that in aromatic aldehyde there is no alpha hydrogen. So it is a condensation between an aromatic aldehyde which does not have alpha hydrogen with aliphatic aldehyde or ketone having alpha hydrogen. Example, let us take acetaldehyde. Acetaldehyde is CH3, CHO. In the last class we have discussed, you can write this CH3 can be written as CH2H. Of course, this is alpha hydrogen because CO group attached carbon. This is alpha carbon. In that carbon there is a hydrogen. That carbon is alpha hydrogen. So this type of condensation in the presence of a mild base like aqueous or dilute NaOH. Look at it here. This is aromatic aldehyde. Example is benzaldehyde. A benzaldehyde, that means which do not have this aldehyde does not have alpha hydrogen. It is condensing with aliphatic aldehyde having alpha hydrogen. So as we discussed in the previous class, what is happening? The actual mechanism is same in aldol condensation, same mechanism. So in a simple way, how will you represent this proton? This hydrogen will be migrated to this oxygen. So this bond breaks from oxygen and it will join with the carbon. So what we get? We get a condensed product like this. You can see that here it is CH, and of course here it will become OH, and since this bond is joining with CH2, CHO. Correct? First we get this aldol, and which upon dehydration minus H2O on heating. How minus H2O is removing? I am writing the same structure once again. Look at it here. Here it is CH, OH, and next CH2 can be written as CH, H, and CHO. And what will happen? This H2O will be eliminated, and you can see that what we get, the final product, you get a product like this. Here it is CH, double bond CH, single bond CHO. This is alpha beta unsaturated aldehyde. This aldehyde is known as cinnamaldehyde. What is that? Cinnamaldehyde. Okay, this mechanism, this condensation reaction is known as Claisen-Smith condensation. Like our aldol condensation. In aldol condensation, that is this is a cross condensation. In aldol condensation, same molecules of aldehydes or ketones are joining together. Same molecules, similar molecules of aldehyde or ketone are joined together, and we will get aldol, which upon dehydration we will get alpha beta unsaturated aldehyde or ketone. Here only the difference is this is cross aldol condensation. One molecule is aromatic aldehyde and the other one is aliphatic aldehyde. This type of cross condensation which will result in alpha beta unsaturated aldehyde or ketone, and this type of condensation reaction is known as Claisen-Smith condensation. The entire mechanism, is similar to our aldol condensation. First one is aldol formation, second is aldol dehydration, and we get alpha beta unsaturated aldehyde. If you take a ketone, suppose instead of acetaldehyde, if you take acetone, CH3CO CH3, what you will get here? You get the corresponding ketone. Okay, that's all about Claisen-Smith condensation. Next is next condensation reaction, that is Perkin condensation reaction. So third one, first one is aldol condensation, second one is Claisen-Smith, and third condensation reaction is Perkin condensation reaction. Okay, listen very carefully. What is Perkin condensation reaction? In Perkin condensation reaction, like our Claisen-Smith condensation reaction, an aromatic aldehyde, that means aldehyde which does not have alpha hydrogen, condensed with an acid anhydride, aliphatic acid anhydride having alpha hydrogen, to form an intermediate which upon hydrolysis and dehydration will give alpha beta unsaturated acid. So listen to me. What is Perkin condensation? This is important. Perkin condensation, it is a condensation of an aromatic aldehyde. Aromatic aldehyde means aldehyde does not have alpha hydrogen with an aliphatic acid anhydride. What is the general formula of anhydride? RCOOCOR. This is a general formula. Anhydride, aliphatic anhydride having alpha hydrogen to form an intermediate to form an intermediate. This will condense together to form an intermediate which upon hydrolysis and dehydration to give alpha beta unsaturated acid. So Perkin condensation is very important. It is the condensation of an aromatic aldehyde with an aliphatic acid anhydride having alpha hydrogen. First we get an intermediate. This intermediate upon hydrolysis followed by dehydration, we get alpha beta unsaturated acid. Now this condensation is taking place usually in the presence of a base, and that base is the sodium salt of the acid from which the anhydride is formed. So here the base is, the reaction is taking place in the presence of a base, and that base is the sodium salt of the acid from which the anhydride is formed, Okay, don't worry. When we take an example, you will come to know what is the meaning of sodium salt of the acid from which the anhydride is formed. So first you study what is Perkin condensation. Now let us go through the reaction. So what is Perkin condensation? It is the condensation of an aromatic aldehyde with an aliphatic acid anhydride having alpha hydrogen to form an intermediate which upon hydrolysis and dehydration will give alpha beta unsaturated acid. And keep it in mind, the reaction is taking place in the presence of a base, and the base must be the sodium salt of the acid from which the anhydride is formed. So keep it in mind, it is a condensation of an aromatic aldehyde. Again you are taking benzaldehyde, ring CHO. This is benzaldehyde, aromatic aldehyde. Benzaldehyde, okay, is condensing with acid anhydride. What is the general formula of acid anhydride? RCOOCOR. Here I am taking, instead of R I am taking CH3 CH3. This is anhydride RCOOCOR. Of course, you can see that the CO group attached carbon. This carbon is alpha carbon, and these hydrogen atoms are alpha hydrogen. Similarly, this is also alpha hydrogen. Anyway, look at here. Okay, CH3. I can write CH3 as CH2H. Okay, keep it in mind. CH3 as CH2H. So, and look at here. In the presence of a base, what is our base? The sodium salt of the acid from which the anhydride is formed. From which acid this anhydride is formed? This anhydride is formed from acetic acid CH3COOH and another molecule of CH3COOH. It will undergo dehydration minus H2O, and what we will get? We will get this anhydride. Okay, so keep it in mind how this anhydride is forming. Look at here, CH3, C double bond OH. Another molecule of acid, CH3, C double bond OH. I am writing from right to left. So what will eliminate? H2 is eliminating, and what we will get? We will get the anhydride CH3, CO, CH3. So this anhydride is formed from acetic acid, two molecules of acetic acid undergo dehydration, and we get this anhydride. That means this anhydride is formed from acetic anhydride is formed from acetic acid. Acetic acid is CH3COOH, and sodium salt of acetic acid, that means CH3CON. This is the base. So if the reaction is taking place in the presence of a base, then we will get an intermediate. That intermediate undergo hydrolysis, that means H3O plus hydrolysis followed by dehydration, heating. What we will get? We get alpha, beta unsaturated acid. So look at here how this, here you can write CH3, okay, or now look at here, or it can be written as CH2H. How the reaction is taking place? The mechanism is similar to our aldol condensation beginning mechanism. Anyway, no need of detailed mechanism. So we have explained in the previous case. You can see that one of the alpha hydrogen, it is shifting to oxygen. This bond breaks from oxygen and it is joining with C. And what we get? We get a structure like this. So here it is. Okay, here it is no change. Here it will become CH. This H is here, CH, OH. And what is happening here? Here it is CH2. And here you can see that CO. And here it is O. And here it is C double bond O. And here it is CH3. First we get this intermediate. This intermediate upon hydrolysis. First hydrolysis. Then, okay, hydrolysis, acid hydrolysis, H3O plus. What will happen? You can see that the product is, look at here, upon hydrolysis, what we get. Look at here, here it is like this, CH, OH, and CH2. This you can see that CH2, CO, then this part CH3CO, this will become OH. So here it will become OH. Okay, another molecule, what will form? Okay, CH3, here it is CH2, COOH, okay, COOH plus what will be formed here? Another acid, what will form? CH3, C double bond O, this part also, this is also CH3, COOH. Very simple. See, hydrolysis means giving you water. Look at here, if it is HOH, hydrolysis means reaction with water. This H plus, this will be taken by this. So what will happen? This part will change into COOH. That's all. Here it is COH, and this OH will join here. So what will get? CH3 COOH. Very simple. One molecule of water is added. H is joining here. So what will happen? COOH. Here it will become OH. That's all. And this OH, here it will join with OH. CH3, C double bond O, OH. That's all. Okay. So that's all. One molecule of water is added, and you get this acid and this acid. Okay. Now look at here. This acid. This is our major product. Acetic acid CH3. This is our byproduct. Let it be there. It is eliminated. And this acid will undergo dehydration upon heating. Upon heating means what is that? How will you write upon heating? Again, I am writing the same structure. Here it is CH. OH, and in the previous case you can write this compound, this CH2 can be written as CHH, correct? CHH, because this is alpha hydrogen, CHH, and here it is C double bond O, OH, or you can simply write COH. Okay, now what is happening? H2 is eliminated, and here it will become a double bond, and what is the final product? You are getting a product like this. Okay, here it is like this, and a CH, double bond CH, single bond COH. Okay, this is known as C, alpha, beta. This is C double bond OH. CO group attached carbon, alpha, beta, unsaturated. This is acid, alpha, beta, unsaturated acid. This acid is known as cinnamic acid, cinnamic acid. Okay. So that's all about Perkin condensation. Hope you understand. And thank you. We will continue in the next class.